Hello, everybody, and welcome one more time to the Ken Seminar Spring Series. Today, we're very excited to host Ryan Walsh. He's the CEO and founder of Valqari and the North American chapter director of the drone logistics ecosystem. He focuses on the infrastructure needed for drones to become a seamless part of society, holding 35 granted intellectual properties. Mr. Walsh earned a bachelor's degree in economics with a minor in political science from Northeastern Illinois University and an MBA in management from North Central College. Please all help me welcome Mr. Brian Walsh. Ryan Walsh.
Thank you so much for having me. I really appreciate everybody taking the time. Yeah, a little bit about myself, as you so kindly alluded to. Yeah, I'm the CEO and founder of Valqari. Really got my first experience with drones about 20 years ago when I was in the Ranger Regiment. It was when drones were first entering the battlefield. But back then they were the large Predator and Reaper drones, nothing like we're seeing today. But it really started getting my mind going on this, and that's really led us to quite a bit of accolades. We've been getting a lot of press, winning a lot of awards lately. So we've been getting a lot of attention on some of the stuff we've come into. But let's start with the drone industry itself. For those of you that aren't familiar, the FAA Reauthorization Act just passed May of last year. It's the first time in probably about a decade we've gotten any real clear, concise guidelines from the FAA as far as timelines for drones. Now, everybody I've spoken to, and I'm on a number of different boards, there's a lot of hype around the air taxis, but if we can't get the small goods, let alone the small packages, we can't get cargo, we can't get people, right? So I always tell them, if we can't get a good timeline on the small drone deliveries, the air taxis are not going to happen, right? But they will be about 5 years behind the drone side of it from everything I put together. But what we're seeing here is this year, and in that FAA Reauthorization Act, it was scheduled for September 16th of last year. The FAA is behind, shouldn't say as usual, but as usual. So it should be coming out any day now, right? It could be in the next couple of weeks, next couple of months, but this year is the watershed year we're seeing for drones finally being capable of beyond visual line of sight. Now, for those of you that aren't aware of what BVLOS or beyond visual line of sight is and why that matters, currently the regulations and what they've been for the past 10 years in the United States especially, but Canada and Europe as well, is the pilot has to be able to see the aircraft at all times, right? Which you can imagine based on terrain, elevation, buildings, things like that, could be anywhere from a few hundred feet to maybe a mile, mile and a half in a really good area. And so that limits your capabilities of doing operations tremendously, especially when it can vary so much in the same location day to day just based on weather. And so about 99% of the drone market is closed right now. Almost all of your delivery operations are closed. Quite a bit of your emergency response type of stuff, although that's starting to open up. A lot of what you see commercially viable right now is inspection, mapping, photography, things where the drone can be in a relatively similar location, doesn't have to leave a very far distance. And so when we get these new beyond visual line of sight regulations, it's going to open everything up. China's about 6 years ahead. They've had these in place, and they're just blowing away most of their projections with what these drone companies are able to achieve in that timeline. And so that opportunity is opening somewhere to about $1 trillion by the end of this decade. That's looking at ARK Invest, McKinsey, Roland Berger, even Amazon did some studies, and the market is absolutely massive. And we'll get into a few of the numbers, but when you look at every single business, every single industry really that has some need for goods to come in or out, And so I can tell you that was something I learned as a ranger, right? Napoleon always used to say, professionals study logistics, amateur study tactics, right? Getting goods, especially when you're deployed ahead of, you know, enemy lines, it's one of the most challenging parts. It really determines where you can be, right? As a small business owner, it's one of the biggest choke points and bottlenecks that your business will run into at any point is how quickly can you get your materials in? How quickly can you get your finished goods out, right? And so we're finding everything from legal courier services to medical to just even the at-home deliveries. Those are almost the low-hanging fruit in this. And so looking at what it costs right now to get something delivered, whether it's through Uber Eats, UPS, any one of the traditional ground-based deliveries, it's somewhere between $5 and $12, right? I'm sure most of you that are getting goods delivered, right? I Uber Eats stuff all the time. It's about what you pay, right? And the price per delivery with drone is about 22 times cheaper, right? What would cost $5, right? Your margin being razor thin could be you're making $7 on that. Now you're spending a quarter, right? And so that's a lot of margin for the operators, the restaurants, everybody else to kind of make up some of that margin, which is really where we see the adoption curve coming in. And so when you look at not just the existing delivery, but what kind of markets that opens up, it's absolutely huge, right? So looking at not just the parcel delivery, but when you add in just ground robots. So this is a really important thing that ARK Invest did here. They broke out the grocery robots from the food and parcel drones, right? I get asked this all the time. Are drones going to replace trucks? And no, drones will never replace trucks. I think we all saw during COVID, we have a very fragile last mile and it cannot handle a whole lot of additional impact or adjustments to it, right? It's already barely operating under its peak, right? And COVID would push it there, right? So adding drones in, we're going to see a lot better point-to-point deliveries. Think food, think pharmaceuticals, think items where it makes sense to kind of micronize that delivery, right? Versus groceries for a family of four, a flat screen TV, a microwave, that will never make sense to deliver by drones. Trucks will always be better at what we call the milk run, right? And whether that's an autonomous vehicle or a traditionally manned vehicle. But when you think of your mail, for instance, you have a very high density with very short distance between them. Trucks are going to always win in that situation, right? Where drones make sense is you got to think Uber Eats. I'm ordering something. I have to have a driver in a van, a truck, drive 2, 3, 4 miles, grab effectively a hamburger and a drink, no more than 3 pounds, and use the energy to push that SUV, that truck, that van, another 3, 4, 5 miles to my house. It's extremely inefficient. Whereas with drones, if we have a service nearby or at that restaurant, you can now deliver something suited for 5 pounds and to go 3, 4, 5 miles. So the energy ends up becoming a lot more efficient and it ends up taking a lot of those vehicles off the road, right? And so we see that opening up a lot of things like pharmaceutical delivery, which is traditionally an inhibitory market to access. So if you look at just kind of the breakdown, these are really the numbers are kind of mind-boggling when you think about it. One of the big things we see, right, the cost of in-home care, right? It's one of the most inhibiting things for people in hospice and at the end of life, right? And you have an in-home nurse that's there most of the day, but most of what they're sorting is actually the logistics, right? And so then you have this six-figure price tag where you're really sorting out getting medical supplies, getting pharmaceuticals, getting meals to this person. If we can arrange all of that through autonomous deliveries and then have those nurses strictly be there for when they're needed, it ends up A, lowering the cost, but B, making that much more accessible to more people. And so we're looking at those new markets as to how the economics start making sense, right? If you talk to any business owner right now that delivers through Uber Eats or any of these traditional type of last mile delivery meals, the price you're paying on the app versus the price they're charging in store is different because they're already getting hemmed up so much on those margins. The margins are so bad right now that most of them can't afford to stick with it, but they have to because they'll lose a giant market share if they don't. It's a very cannibalistic industry. And so drones really are the only way out of that in my eyes. And so if you look at just the sheer volume of this and kind of where this is going, it starts opening questions that we led to as Valqari, right? Roland Berger points it out in this report that's quoted up here, but there's going to be a new infrastructure required, right? If you purchased a home 100 years ago, didn't have a garage, right? Most of the time it did not have a garage, right? And then now you'd see detached garages 50 years later, and to the point where today you can't imagine buying a house without some form of garage or car storage. And we're going to see the same things with drone infrastructure and vertiports for air taxis. It's really going to open the architectural revolution that's going to come behind this, and that's really where we're focused. Just because when you look at the sheer volume that will end up happening by the end of this decade, it's pretty unbelievable. The numbers, everybody's coming to the same conclusion though. Approximately a 38 to 40% year over year growth for the next 2 decades. Now, there are currently gaps, right? You're seeing with Zipline, for instance, they do the parachute deliveries. If you've seen that, that doesn't solve any of the security issues. It also doesn't have any chain of custody, right? So when you're doing medical deliveries, chain of custody becomes very important. Same with winch deliveries. They don't actually secure the package at the end, right? And so whether it's porch pirates, things like that, a lot of those solutions, while they get it from point A to point B, they don't actually solve the problem of securing it once it's on the ground. And one of the biggest issues is how do you ensure people on the ground are safe? That's really what's been holding the FAA up with drone delivery above all else. How do I ensure that the drone isn't going to interact with a person, or the package isn't going to fall mid-flight or fall on a person when it's falling down on a winch? A lot of those things. Another set of issues we're seeing, the drone industry is very, for lack of a better term, cutthroat. People are very, very afraid to collaborate and share technology. And it's just the nature of being an early stage technology. It's just how things go. But what that's led to is a lot of closed systems. And so we're starting to see that kind of shift over the last maybe year, 2 years, but for the most part over the last decade, it's historically been closed systems, right? You see DJI, for instance, for those of you that are familiar, they don't necessarily work well with nearly any other drone operation or subsystem. And so that's caused a lot of problems creating like new solutions because the systems don't interoperate well, which requires a lot of technology to kind of fuse them together and bring it all into something commercially viable. And when you're building on those types of closed systems, for those of you looking to get into it, it's very, very challenging to get the licenses oftentimes to do commercial stuff. Now, the other thing, and we'll get into it shortly, is the security / emergency of it. That's the biggest thing when you talk to anybody about setting up a drone operation. The public safety officer, the chief of police, or whoever's in charge of that area will come in and say, how do we prevent this from impacting everybody else, right? As much as we're all stakeholders in this, economy, this airspace, this whatever, at the end of the day, things falling out of the sky is bad for everyone. So they'll always step in and say, what are your emergency landing points? What are your risk mitigation measures? How do we avoid all of the things that could go wrong? And so that is a big thing that we've had to work on. But even more so is just going back to the interoperability, right? So for those of you that have studied the smartphone patent wars. It's kind of boring stuff if you're not into that. I know I'm probably rare and enjoying that, but it's very complicated with how many different pieces of intellectual property went into just getting the smartphone into your hands and not holding that up as an industry. And so there's a lot of that that hasn't been worked out in the drone industry yet that I think is coming. That's going to be a challenge for those on the inside for sure. So real quickly, we're going to get into just what is a drone, because I realize not everybody's familiar with, just what a drone is. And oftentimes we just hear, the New Jersey type stuff where it's a lot of hype. But really a drone is any piloted aircraft without the pilot on board. It's as simple as that, right? So it could be a giant, Boeing 737 size drone with the cockpit changed out to robotics, and there's a lot of cool stuff happening in that regard, all the way down to the little toys and DJIs you buy in the store. But it really is just an unmanned aerial vehicle that is intelligently controlled. You don't really think of like the model rockets you light off, back in summer camp as drones per se. So usually that piloted piece is the critical part. But these are the main components in this. I would ask you guys to point them out, but to save that, we'll just jump right to it. So you have your airframe, which is the drone itself, but then you have the flight controller. So this little orange box at the top, that's your flight controller. That runs just about everything on your drone. That's the brains of your drone as far as all the flights and movements and everything else. And so that goes to what's called your power distribution board. And that goes to your ESCs, to your motors, right? And so your power distribution board is telling the battery how much power to put into each one of those motors, and the motors is spinning it through the electronic speed controllers, right? So you can burn out ESCs and motors quite easily, but it's very difficult to burn out flight controllers or power distribution boards, things like that. Your GPS just tells you where you are, and then your communications modules are what just talk to you as the pilot or the FAA. And then you get into specialty components. Now, one thing with drones people often forget is they're really just tools, right? They're just a way to bring your cameras, your sensors, whatever it is, into an environment you might not normally be able to get it. And so all of the mission capable stuff, the things that are doing the mapping and finding the pollution and doing the delivery, all of that is on these specialty components, right? The drones do not differ on the last slide, drone to drone, other than make and model and size of those parts. Nearly every single drone in the air has all of those parts. When you get to these specialty components, these are where you kind of pick and choose to make your drone as mission capable as you possibly can, right? So you'll have, first and foremost, this companion computer. This is usually a Raspberry Pi or a Jetson, and this controls everything else that's not flight related, right? So the flight controller handles all the flight and everything related to that, but if it has to do with the landing, the communications, the autonomy on the drone itself, the package retention, all of that is run through your companion computer. And so you can often, connect through some internet modem. We use a few different ones. But that's often becoming a requirement on drones these days. Very rarely do you see an unconnected drone. But then you have all of your kind of mission stuff, your grippers, your cameras, range finders, although parachute systems are becoming more mandatory by the day. Those are likely going to be required in this next beyond visual line of sight regulations that should be coming out any week now. And so we talked about the flight controller. Those tend to run really what's your autopilots, right? Rarely do you see a drone without an autopilot unless it's like one of the racing ones. Every commercial drone runs an autopilot that I've seen to date. And they come in really these three flavors, and there's a handful of little sub flavors here, but think of it like your Android and your iOS, right? They're just kind of two different, Apple and PC, right? These are the same ones. Usually you're kind of tech siloed when you pick one, but not necessarily. But they're kind of just the different languages that these all run on. So we usually run ArduPilot and PX4, but we do sometimes do DJI. I mentioned it is a little bit harder to work into, but each one of these has pros and cons depending on what you're looking to get into. And then you have all of these kind of background components, mission planner, Qt ground control. Those really do all your flight planning and your mapping for your mission. You can run simulations. They have UTM, what's called unmanned traffic management. That's a requirement these days if you're running bigger operations. Smaller operations, you just need what's called remote ID, where your drone's just transponding your location and some of the telemetry. But UTM is where you actually have, air traffic control on the drone level. But now we get into, imagine in a few years, right? You can order something by drone. I want to get food after class. I want to get a new phone charger, whatever it may be, right? How will that drone actually get to you, right? This is a robot with anywhere from 4 to 8 spinning blades, usually up to 55 pounds. If this thing comes within your personal space, it's dangerous. So what happens when you order something? And so that is where Valqari really comes in, is we started looking at the infrastructure and why it's so critical. But where do these drones store themselves when they're not in use? Where are they charging? If you have an emergency mid-flight, where does that drone stop off at, right? Do you want drones stopping in the middle of a walkway? You definitely don't want it coming down in a road because you just took a bad situation and turned it into a nightmare, right? So what do you do when you have a drone at 300 feet that all of a sudden has limited mobility and has, maybe 50 feet of navigational space before it's hitting the ground, right? You have to have different pieces of designated property that drones can more or less use for emergency ditch points. That's something we're working on at Valqari, amongst many other things, but these are the problems that I think people are starting to look at, right? When you think of a drone crashing on somebody's property when they were getting a delivery, right? It's going to be the homeowner insurance and the flight insurance that start fighting it out and asking the questions of who's at fault, right? But you scale that all the way out to 10 years from now, right? You put your kid in an air taxi and it has a problem and it has to go to one of these emergency ditch points. Right? Now you have the police showing up saying, why wasn't the kid being watched, right? There's different laws that I think need to be kind of set in precedent, or will be set in precedent, that are leading to some interesting questions as far as what this technology is going to open up. But I think this emergency question kind of opens the door on the beginning of a lot of it, of just what happens when it doesn't go perfect, right? And so that really comes to the importance of the infrastructure, and why I've been so focused on it is, whether it's, my past training as a ranger, whatever it may be, I always look at the worst case scenario and what that contingency plan is. And that's really why we found that turning the whole idea on its head and figuring out what is critical for, not just convenience, but the emergencies and the non-routine as well, right? And so you kind of picture where the cities of the future go, and we're going to have a lot of these pieces, right? When you think of how much of our cities to date have been just revolved around the car, right? From the highways, the garages, the driveways. We have entire cities that really are based on driving, and everything else, whether it's commercial, whether it's living, whether it's just general happiness, are not really thought of as main things. Those are byproducts of car living, right? When you look at a European city, it's laid out very differently, but we're going to have to start thinking through a lot of those kind of civil engineering designs and kind of layout designs of how do we want this next generation of city to look, when we start talking about parcel deliveries and air taxis and things like that, because it adds a whole new dimension to just the city layout and the architecture, and it's going to bring in a lot of benefits, but a lot of complications as well. And so get into Valqari's tech just a little bit. See if we can get this to play. So this is a demo we did. That gentleman puts a package in one of our 6 lockers. It gets brought onto an elevator. It's about to center the drone. So that centering mechanism is really important because it allows us to work with any footprint of drone. We can always get it over the elevator every time. But once that package is sorted, it gets raised on an elevator and put up on the drone. The drone's going to grab it. While it's doing that, it's talking to the FAA over that UTM, right? So it's actually doing an airspace check, and it's making sure that the airspace is clear and that it's not going to run into any other drones or anything that will complicate the flight. So once it gets approval, it takes off, it flies. This is going to be a short one just because it was a demo flight, but it flies over to the appropriate landing position. And once it gets there, it sends messages back and forth. And it says, I'm the drone, I'm the landing station. And once that handshake occurs, that landing beacon turns on so the drone can perform that precision landing. But as you can see, it gets centered with those centering bars no matter what. That way we ensure it's always pinpoint accuracy over the elevator. And then the elevator door opens and you'll see the package drop in just a second where it will get sorted. And then placed into one of the 6 lockers before it sends notifications out to everybody that a successful delivery has taken place and to the customer that the package can be retrieved in the locker. But we even put a lot of thought into which lockers are assigned to which customers. For instance, if you sign up as somebody with disabilities, we'll ensure you have the bottom 2 lockers as a priority, just so if you have, issues with being in a wheelchair or whatever else, we try to think through the customer experience to make it as easy for the people we're trying to achieve this for as possible. But every one of our systems can both send and receive. They receive landed, winch, airdropped, you name it. And so how it all kind of comes together from a technical point of view is we build ours very open architecture through API extensibility. So the drones, they're all working off of Python for the most part. They're also working off of the 3 that we talked about, RGPilot, PX4, and then Mavlink is the message type those send. And then you go to your sensors and webs, right? So your sensors are usually running NVIDIA. You have some that run off of ROS, Robot Operating System. And then all your web applications tend to run C++. So we've really had to make more of an interface where all of that comes together rather than trying to build our own. That's the hardest part, again, is the integration. So building open architecture is what we found to be one of the most critical pieces in all of this. But how it all works is you have your microcontroller, right? And so it's sending your Mavlinks, like we mentioned, which is then going to your Raspberry Pi, which then goes to your cloud, which then goes to your web interface, right? Or to your box. So it's a rather cloud extensive process, but that allows us to be very efficient when it comes to connecting through APIs. So here's a little bit more just kind of on the back end of how some of that works. But it allows us to, again, if we have customers that have existing fleets, 50 drones, for instance, we don't want them to say, hey, you have to go and get all new drones, right? We can say we have this set of landing stations that'll work for you, this set of software that we think will work for you. We can all integrate with your existing drones with minimal changing. So that's what we found to be very important, whereas a lot of other companies have kind of fallen on their faces because they try and get you into their tech silo and keep you there, and that usually comes with a premium cost too. So a little bit about what we're working on. We're working on our single locker and our rooftop system, which we're quietly testing right now. This year we are hoping to get our Skybridge out, which is a large shipping container version. For those of you that are familiar with patents or aren't familiar with patents, whenever you get something patented, it doesn't cover the size or shape. Really, it just covers what's in the claims, right? And so even though our claims are for a drone storage locker and landing pad, we can scale that up to shipping container size, even bigger. It's all still covered under our patents, which is fantastic. And then as retail starts getting more and more into people's homes, right? When these new regulations finally are released later this year, we expect it's going to take a little bit of time for people to start adopting it, but then we'll start releasing our window and mailbox and even our mobile kiosk unit. But we do think that there's a lot of places these are going to make impacts. And these are some of the ones we've been looking at already and working with companies on, but campuses and stadiums. So we've done delivery at golf courses. We did deliveries at Purdue for some of their baseball games. And what we found is it's very exciting for the people there, but it also provides a very solid convenience. But hospitals, we just did a big one with Northwestern Medicine, and we're expanding that one right now. Mixed with the rural, when you think about rural pharmaceutical deliveries, it has the ability to close what's right now a $300 billion a year problem in pharmaceuticals that aren't picked up, that are filled by the pharmacies. So solving some of those problems, which we're hoping can help lower the cost of healthcare and increase the access, is very important. But even fire, right? So some of the stuff we're working on, we're hoping to showcase soon, is using our same technology just to help first responders, right? So think landing stations that are strategically placed within the community. But when somebody dials 911, it already has Narcan or an AED or epinephrine in there, and is able to dispatch those to key locations within seconds and cut some of that time for those emergencies, where those seconds often is the difference between life and death. But also doing the same thing with fire response. So we are testing some pretty cool stuff right now that we're hoping to announce pretty soon, but those are some of the key areas we're looking at. But yeah, looking forward to answering any questions you guys may have, and really appreciate you taking the time to listen to me.
Thank you so much. We're going to start taking questions from the audience.
Please.
Well, I will start. Thank you so much for the presentation. It's quite interesting. And I wanted to ask you about what is your vision for this business model? Is this just a service as a service, or do you intend to also supply the hardware for whoever company wants to use the drones to deliver their products?
That's a great question, and actually something that keeps me up at night. We started our business model when we first commercialized at the end of 2021, being an OEM, where we predominantly were manufacturing and providing them to drone integrators and operators. The market was evolving in a way where you had, similar to where we see now with trucking companies, right? GM, they don't run trucking, they don't run taxi companies, right? We saw the same thing in drones, where those operators and integrators became the trucking and taxi companies that were buying the equipment and then running them for customers. But what we found was those companies had a very tough time, whether it was raising money, getting new business, or market share, whatever it may be. And so they were very difficult from just being a customer point of view. They took forever to pay. Sometimes they wouldn't pay. They were just very challenging overall to work with. And so that's when we switched at the beginning of 2024 to more of a white glove service for the Fortune 1000 companies like Northwestern Medicine, as well as licensing our technology, which we've been kicking off this year in earnest. So while we still do the manufacturing and still can provide the technology at a hardware level, we found that we've had to meet the customer closer to where they want to be.
Okay, thank you so much. We're going to take questions now from the audience. Go ahead, Professor.
Thank you very much for the very interesting presentation. A quick question: you were showing the demo of a drone. You say you check with FAA for the route clearance. I'm just wondering, like, if you do a little longer distance delivery, do you in real time communicate with FAA, or you have a mechanism to try to avoid say emergency happening, another drone just also take off at the same time and they have their paths cross each other, and how do you deal with that?
So that's a great question. What you're describing is actually the difference between level 4 and level 5 autonomy, right? And so level 4 autonomy is what we run. That's waypoints, right? So we check with the FAA. It's pretty much real time. And then you also have remote ID, which is a beacon that's similar to ADS-B if you're familiar with the flight side. But it's literally just sending off a ping to the FAA every however many seconds. Here's my position, here's my flight path, all of this. Now, when you get into level 5, which is really detect and avoid added in, that's where, as you mentioned, the drones are actively avoiding each other, right? Now, there's a lot of ways you can do this. Traditionally, people assume you have to have some type of detect and avoid on the drone, which usually is camera-based or some type of sensor-based. And why that's never really taken off, no pun intended, is it's just very heavy and very power required, or power-heavy requirements. And so you end up having these drones that you add in detect and avoid, and now they can't carry cameras or payloads or anything else because all of the system is, or all the extra weight payload has gone to the detect and avoid and extra batteries for it. So we're seeing new things pop up like ground-based radar, which I'm really excited to test this year, where you'll see really is exactly what it sounds like, ground-based radar that's kind of scanning the whole sky, going back into some central server that you're talking to, and you're really getting your airspace checks that way. So if the ground-based radar detects something coming your way or two drones on a path to collide, it would send out the messaging to both parties to, change their routes or whatever it may be. So there's interesting ways coming out that I think are going to solve that pretty soon.
Thank you.
Okay, go ahead.
Yeah, thank you for the very nice presentation. I had a simple question because I know like for some buildings, like including where I live, there are already like some locker system, for example, like the Amazon Hub. So I was wondering if your technology can be compatible with other lockers, or does it have to be like a Valqari locker?
It's something we've spoken to other parcel locker companies about, and that's where we get into the licensing piece. We're more than happy to license our technology with just about anybody because we realize we can't solve everything for everybody, and other companies have, existing locker space or, contracts for the real estate or whatever else in place. The other piece of that is I filed a lot of my patents around the different architectural requirements. So rooftops, balconies, windows, the sides of buildings where it rotates in, even ground-based and everything else. And so, realizing that every building, every area, every zoning code is different city to city. We tried to find all of the ways we could get solutions for customers so we wouldn't be the friction point in that chain.
Thank you.
Thank you for the presentation. I just had a question about the safety because you mentioned that you're thinking about it and like how to make it more safe. And for those like locker systems, I was imagining something like more visual, some kind of like noise or sound or color, lighting, like to signal people that there is a package coming, and if they don't want like the drone flying over them or some. Have you thought of something like that?
Those are great questions, or great points. We actually recently got patents for that exact thing. It is something we've been working on. The demo I showed you was in our parking lot, and we run the risk sometimes. For instance, at the hospital, they don't want any noise, they don't want any lights, they don't want any patient distractions. Golf courses, same thing, right? In public spaces, you absolutely need to have lights where you notify people of, is a drone incoming? Is it safe to approach? Things like that. And so we haven't publicly shown it yet, but we do have a few of those already built. So yeah, you're spot on.
One more question. Do you think there is potential in drones to become a general service, and for instance, to become like a taxi app where any user can call any drone in the network, ask it to pick it up, some packet, and deliver it wherever I need it to be.
I think that's a great point. Yes, I think that's one of the business models that will evolve from this. And I think very much like we saw with smartphones and apps and the different types of business models that came from that, that we never probably anticipated in 2007 when the smartphone was released, right? But I do think that we're going to see first these third-party deliveries that are going to do these, Uber Eats types deliveries for food and medicine and things. But then once you have the landing structures, you have the points at your home, and there's all of this infrastructure in place, there's no question we're going to have peer-to-peer deliveries that are going to open up where people are going to moonlight their commercial delivery drones for those types of things at some point in the future. So yes, I think that amongst many others are probably going to be developing business models as this starts to kind of become more mainstream.
Thank you so much. Is there any other question in the audience? One last clarification. If we want to run the Valqari system in any drone that we have, what is what we need? Is there any minimum requirements in terms of hardware for compatibility to be able to run the system as it is right now?
So what we look for is, can the drone and the landing station speak first and foremost? So is the drone going to be internet accessible? And then if it is doing deliveries, for instance, that it can carry the weight we're looking to mix, and then it has a gripper mechanism that can pick up or drop off the package. But that's about it.
Right. Well, if there is no further question in the audience, please join me in saying thanks to Ryan Walsh for this great presentation today.
Thank you so much for having me and taking the time. I really appreciate it.